Yes, yes,
Yes, sir.
Venkatesh.
Audible.
Yeah, thank you very much. So let's begin with today's session. So the firstly, we'll let know what the topic is. So it's motor positioning in electric two-wheeler. So I suppose there are a lot of things has been like in talk recently about electric vehicles, especially about electric two-wheelers, and it's uh, the segment where electric vehicles are like it's getting occupied a lot. Not that much of craze is being going on in the four-wheeler domain, but two-wheelers are catching the market, electric two-wheelers. So I hope this session will make you aware about all the aspect of electric two-wheeler from the motor perspective and the positioning of motor, how it affects the overall performance of vehicle, and when it comes to buying a vehicle, or when it comes to especially from engineering perspective making the vehicles, how does it affect and what all things has to be considered. So all those things we will trying to cover in this session. And let's first start with what is the overview of today's session. So firstly, we will know a little bit history of electric two-wheelers, how it started, and what things were there initially. Then we will talk about a little bit what different types of motors are used in electric two-wheelers. Like there are different types of motors, so what specific motors can be used. Then the very important topic, and I suppose the whole session will be walking around this particular topic itself, which is a hub motor or in-wheel motors. And then we will also talk about some calculations based on hub motors, how they can be selected or what are the parameters. Then some limitations of that using hub motor in electric two-wheelers. Then we will see what is the architecture of electric two-wheelers using mid-drive motors. So that's the thing we will talk about. And lastly, we will compare the things that we talked previously, basically the in-wheel motor and the mid-drive motor. So we'll try to compare what are the advantages and disadvantages of having each type of architecture in a vehicle. And I would love to have discussion from your guys as well if you take part in that. Okay. So let's begin with the first thing, the history of two-wheelers. So when vehicles were introduced, basically before the IC engines, motors were developed, and the motors were installed in the vehicles. So in 1890s itself, people started making the concepts and the design for electric two-wheelers. And you can see this is like a design from an engineer in 1980s. And people started thinking like that before into building of electric two-wheelers. Then people came up with some prototypes and practical models of that, and they were like for prototype at a prototype stage and not mass produced thing. But since there was some research and development done in motor technology, as well as some batteries also got popular that time. So companies they started building commercial models of that, and mass produced the electric two-wheelers for the public application. And people also started buying it because it was easy to travel instead of paddling and all. You get very ease just to connect your battery to battery motor into the your bicycle, and you no need to run the pedals at all. So people started believing in this technology and people adopted it. But since the revolution in IC engine technology happened, and fuels were available at less cost than the batteries, and batteries were not that much efficient at that time. So here I would like to ask one question: what do you guys think at that time? Which kind of batteries were being used?
Lead acid battery.
Yeah, great. So I couldn't read your name. So yeah, I really appreciate your
Hotel
answer.
Herschel. It's enrollment number of college. So
Okay. Yeah, no worries. So yeah, thank you very much. So at that time, there was no such lithium ion or nickel cadmium technology or alkaline batteries. So there was lead acid batteries. So those were the only batteries or the type of batteries were available, and they have to be. They didn't have that level of energy density, and they were bulkier. And compared to IC engine, they were like not that much of power delivered. So those things affected the reduction in the number of adoption of electric bikes. And then people started adopting IC engine vehicles, those two wheelers. So that's the bit about history. But now, since we all are realizing that the harmful emissions which are there from IC engine vehicles, and like there are a lot number of more than four wheelers, there are two wheelers on the road. So they are like polluting the environment at a very high rate. We have to have some solution or alternate to IC engine vehicles, and now we realize it's the electric vehicle. So again, from electric to petrol, and then we are again shifting to electric vehicles. So that's how the situation is changing. And now that the day will come in future where all the IC engine vehicles or the basically two wheelers in some years might get replaced with the electric bikes. So that sort of thing is surely gonna happen, and people are predicted that. So that's the history of electric two wheelers. And currently, we know there are a lot of startups and OEMs making electric two wheeler for the public application. And few of them, like the companies, got really popular in that domain, and some players have been like building this vehicle for past 8-10 years, but they haven't got the market yet. But since it's a booming era and everyone is talking about EVs, so a lot of startups has also came up with their models which satisfies the customer requirement. So few of them you definitely would know which models have been put here. Like there is a Aether, Ultraviolet, then Okinawa, Revolt, such companies like we didn't heard that name before, but Hero Electric, they have been building electric vehicles for a quite long time. But now in past 2-3 years, their name has come up. So that sort of things are happening currently in electric two-wheeler market. And in future, there could be more futuristic or some advanced kind of vehicles that we will see. And as an engineer, if we are working in this technology, so surely we can have very fancy looking and futuristic sporty bikes. So that will also might happen if we guys work dedicatedly on these technologies. Okay. So this was the background I wanted to create about the electric two-wheeler here. And now we will talk about different, like in electric vehicle, the main or the prime mover is not engine, but the electric vehicle, the electric motor. So we'll see what different types of motors are available in the market, and which specific can be used in electric two-wheelers. Okay. So there are basically two types of motors, DC motors and AC motors. And when DC motors were developed, initially it was brushed motor itself, but due to they have very much friction in them, and very high noise are there, and they are not that much efficient. So brushed motors are not used in electric vehicle application as of now, and brushless DC motors are what are like very much popular when it comes to their application in electric vehicles. So we'll see about that, how what sort of applications they have. And AC motors are also popular when it comes to electric vehicle related application. There are synchronous AC motors, then induction AC motors, which can be run on three-phase, single-phase, depending upon the power requirement. So these kind of motors are used in electric two-wheeler application. So now we will talk. I would like to tell you some difference that the picture I will show. Okay, so not from the visual perspective, but see from as an engineer or from the technical perspective, what all difference you find in these two electric wheelers. So can you guys let me know?
Yes, sir.
Sir, first of all, the battery, I guess.
Battery. So what difference you see in terms of batteries? I don't see any batteries yet here.
So, means
Wheelbase, it is
Yeah, wheelbase you can say. Definitely. Yeah, correct
yes,
answer.
sir, wheelbase is there.
Here wheelbase.
Front disc brake, sir.
disc brake.
One is
Yeah.
powered by motor, sir. Another one is
So here there is no disc brake, there is a disc.
Hub motor.
Yeah,
hub motor.
hub motor, exactly. So that's the thing I was looking from you guys. So here you can see it's there is no motor. Motor is somewhere inside the body, and it's connected with the chain or belt drive. And in
Yes,
this
sir.
case, here the motor is already available
And
inside
the
the
rear
wheel.
wheel.
Exactly. So I really appreciate you guys notice the exact difference. Yeah, so that's a great thing to have conversation. Now, as you guys have already noticed, like there is a hub motor available here, and there is a mid-drive motor, what we call it as. So mid-drive means it's located at the mid of the vehicle, and the vehicle is run with the help of some chain or belt-driven mechanism. So these are the two things we will be basically talking about in today's session. So let's get started with the hub motor. Okay. So this is how hub motors look like. Inside it, there is a motor winding and magnets are there. And so in some cases, the drum brakes are also available, integrated in the hub motor. And in some cases, disc brakes are mounted over the motor. And this is the rim where we can attach the tire for the application. So if you can see, this is how it is mounted on a vehicle, mostly in the rear wheel. So we insert the complete motor and we just mount the tire on it, and it runs directly attached to the motor. So that's how hub motors or in-wheel motor works. And let's see different properties of hub motors, which all types are there, and which advantages, disadvantages it has. So let's talk about that thing. Okay. So hub motor, it is only possible or like more efficient to build with the BLDC basically. So it's only available in BLDC segment. Then it is compact. As you can see, the width of the motor is very much compact, and it can be like it's flat basically, we can say, and it can be directly mounted inside the wheel or hub. Then it's easily mounted as we talked. Then it what one of the properties, it provides high initial torque. So may I know what do you guys know what the torque exactly is? Because
Yes,
there are
sir.
some
Force
technical
into
terms.
this
If you
torque
guys
torque.
are not aware of, could you please repeat?
The
Force
torque means the acceleration provided.
or
No, I didn't get the correct answer. Okay,
Could
so
you please repeat a question?
yeah, so I am talking about what exactly is the torque or definition of torque. If you guys can let me know.
So the twisting force is the torque.
So basically, let me tell you what torque is. It's the external agency that causes the rotational motion. Okay, so if there is a thing, some object is there, and if you want to move it linear in a straight path, so you have to provide the linear force. So this is the force. But if there is an object and you want to make it rotate, what you have to do, you have to provide a torque to it. And what torque exactly is? It's nothing but this uh, object from the
Force
object
into distance.
4 into the perpendicular distance.
Okay. Yes.
Okay, so that's the torque basically. F torque is equal to F into R. So what happens in vehicle application? You have to rotate this wheel. Then only you will be able to move the vehicle in a forward direction. So in order to cause the rotational moment, you have to have torque. And higher the torque, the more quicker it can achieve the initial speed and gain the speed and being in motion. So that's the funda of the torque. And the motor which has higher initial torque will surely gonna give you best performance in terms of having a good initial acceleration. So yes, BLDC hub motor suits that thing, and it covers that thing, that it can provide high initial torque when vehicle is at rest. So when vehicle is not moving, you require a high amount of torque, because when motor is running, torque is not that much required, but at very initial condition, there has to be a high amount of torque. So that BLDC motor is sufficiently providing. Then apart from that, it is very low cost. So as compared to other types of motors, BLDC hub motors are low in cost. So manufacturer, they tend to, in terms of having a overall cost reduced, they use the hub motors into their vehicles. So that's the one of the thing associated with in-wheel hub motors. So that let me just erase these things. Yeah, so there could be other things as well which could be benefit of having BLDC hub motor. So if we are using, let's say, hub motor, here in this model you can see there is a motor attached in a wheel. So what advantages it will bring into the motor is if it is not placed somewhere in the body, that space you get vacant, and in that space you can put extra batteries. Okay, and may I know putting extra batteries how it will affect the overall performance of vehicle?
Decreases, sir. Decreases. Overall performance will be decreases, sir, due to load.
Load, yeah, that's the thing. But if you are using a specific like high specific density battery,
More distance we can
Furthermore,
travel.
decreases, sir.
It will increase the runtime.
runtime, exactly. So what advantage it will bring is if you are placing a little more battery, it could give you high range can be increased by having more battery. So that space can be utilized for putting more battery, or you could also get more boot space to keep the helmet and all other stuff, or some extra accessories if you are attaching with the vehicle, like if it's not being used just for like a riding experience but for other commercial aspect as well, so that space can be utilized for those purpose. So that's the one of the advantage of having BLDC motor. Okay, and one more thing it will give you is, as you don't have to have additional rims, the tire is mounted on a wheel itself, on a motor itself, so the cost of having the wheel rim in the back would be reduced basically. So that two advantages we can say it brings, and
Sir,
along with that,
there are no
yes,
power losses. It's
no
main
power
advantage.
transmission losses
Yes.
basically we can say. Yeah, so as motor is directly connected with the wheel, we are not having additional chain or chain sprocket mechanism or belt pulley mechanism or any gear mechanism. So transmission losses they gets reduced. So that's how we can get a better performance in that aspect.
So one doubt, sir. What happens when the tire gets punctured?
Yeah, so as some technology come with good advantages, there are certain disadvantages as well. So who's this? I guess it's Mohammed Salman. Yeah,
Yes,
Salman, we
sir.
will talk about that part when we compare both kind of things. Okay, sure. I really appreciate you putting such concerns. So these are the things about in-wheel hub motors. Now we'll talk scooter 10-inch rim if you are having. So motor that can be attached there. Then 36 is the voltage, operating voltage that the motor runs. Then this 250 is the wattage, okay, or power we can say. So 250 watt this motor will have power of, and this is the rated torque. Sorry, rated RPM. I'm sorry, rated RPM. So this is the RPM this motor would give best. Find out what could be the maximum speed of vehicle if we use this particular specification of BLDC hub motor. Okay, so first of all, to calculate the maximum RPM, that maximum speed that we can achieve with this particular we have motor will be used. Okay. Reading the tire specification is also I would say a thing that or engineering student must know. So may I know what are the terms mentioned on the tire? Or are you people aware of these things? So so just go like that. What is this 195?
195 is the internal diameter.
The
No.
section with the
Yeah,
section
section
width.
width,
Imagery
exactly.
section width.
So it's a
And 65 is the aspect ratio.
aspect ratio.
R
Correct.
represents the construction type, radius.
Radial construction.
Construction.
And 15 represents rim diameter.
Exactly.
91
Load.
represents.
Exactly. And amazing. Correct, Venkatesh. I really so we'll talk about each and every term here. So 195 is a width of tire. So if we say in this example, what is this width? Okay, so the work is 195 and it's in 195 mm. So 5 is nothing but the aspect ratio. Okay, so what exactly aspect ratio means? So it's the ratio of this height, basically this height from very top till the rim. So what exactly this distance is? So this height we have to h, we can say as of now. So it's h by w. W is nothing but width. So if we calculate h by w, so and percentage of it basically, so this is the aspect ratio. So how much percentage this height is of the total width of the tire, that gives us the aspect ratio. And then R is the construction, whether it's radial or plied, so cross plied. So that thing we get to know. And 15 is a rim dia. So it's in inches basically. So rim is basically wheel on which the tire is mounted. So here you can see this diameter from here to here. This will be the rim dia, which in case of this tire is 15 inches. So how we can calculate the complete tire radius from here to here? Can you guys guide me in this? How exactly we can do this? Yeah, so I would like to know how we can calculate from the tire specification. We cannot get end-to-end dimension of the. Sorry, can you please unmute yourself?
Sir, 2 into aspect ratio into rim dia, sir.
2 into aspect ratio would
We
not
can
be the answer.
calculate the height through the
rim
aspect.
diameter plus twice the tire
Yeah,
section
we can
height.
add it to the
Exactly. So we have to calculate the rim dia, which is already there. We just have to convert the from inches to meters. Okay. So rim dia we have to calculate first, and we have to add this h value twice because there is one h, and by that end there will be another h. So we will add 2h here. And how we will calculate h? We'll just multiply aspect ratio with the width of the tire. Okay, so not aspect ratio, aspect ratio upon 100 into the width. So that's how we will get the h value, and multiply it by 2 and add it with the rim dia. So we will get the diameter of tire. Okay, so that's how we can calculate the complete diameter of a tire. And in order to calculate the speed of the vehicle, maximum speed, so what we have to do is vehicle speed is equal to r into omega basically. So r is nothing but the tire radius. So whatever diameter we found, we'll divide it by 2 into omega is 2 pi n by 60. So s and tire radius that you get from there, you just have to multiply all these three terms. You will get the maximum speed of the vehicle at that particular motor. So that's how you can calculate the maximum speed that you can achieve by installing a particular specification of hub motor. And there are like multiple specifications are available. This is like very low category vehicle, so it's just around 0.25 kilowatt hour of motor, but there are 0.5 and 0.75, then 1 kilowatt hour of BLDC motors are also there, hub motors that you can use. And but RPM is limited here. You cannot go like beyond 600 or 700 RPM, and that's the limitation. So if you calculate velocity, you won't go beyond at the max like 55 to 60 kmph you can achieve with using the BLDC motors. So that sort of limitations are also associated with using BLDC hub motors. Okay, on as well when you try to do projects. Okay, so shall we move ahead? You guys, is this clear?
Yeah, sure.
Yeah, cool. So now let's talk about some other aspects of the BLDC hub motor as well. So when motor is seen, we have to see the basically the characteristic of motor, how does it behave, and the parameter it is judged on is a speed versus torque graph, or at what particular speed or at what particular torque, how much efficiency that motor is having. Because efficiency is the most most concerned thing, because until and unless you have a very high efficient motor, you cannot use the power which you are storing in the battery in a good manner. So in order to consume that power to an extent that you would get a very high range, and like range is the first thing when it comes to about electric vehicle, which is a more concerned thing. So in order to get high range, you must utilize the power which is stored in the battery in a very efficient manner, and the motor is the very major component that utilizes the battery. And if motor is efficient, then only we will going to get the best performance of the vehicle and the highest range we can achieve. So motor has to be very much efficient. So when we talk about the hub motors, they are not that much efficient in when it comes to the high speeds. And firstly, talking about the torque. So when speed is low, it gives a very high amount of torque, as we talked. So at low speeds, torque is high. But as you increase the speed, the torque gets reduced. So at higher speed, if you are trying to climb certain uphill areas, you cannot achieve that level of performance with the LDC hub motor. So that's the one thing. And it is also not that much efficient when you operate it at very high torque. So when it's operated with lesser torque, then only it gives the maximum efficiency, which is around 85 to 90%. But when you are using it like as a high torque application, it won't be working in the very efficient region. Okay, so that makes its application limited when it comes to have the performance vehicles, basically. You might have observed that whatever new electric two-wheelers are coming, they are not adopting the in-wheel hub motor technology. They are putting the motors in between two wheels mounted in the chassis. So this is what, because of these limitations that BLDC motor has. But the previous manufacturer previously, what the models they have launched, they have used BLDC hub motor because it was cheaper basically, and it couldn't reach to, like, it couldn't give that much of performance. It is limited to 50-60 km/h speed only. But now people are demanding more performance from the vehicle, so they must adopt some other way, which is a mid drive motors, to fulfill those requirements of the customer. Okay, so that was about the hub motors. Now we'll see quickly about the mid drive motors. Okay, so these are the various architectures available. You can see that like there is no such specific architecture, but just one way we can have the mid drive motors. The motor placed inside the body somewhere, and it can be attached to the wheels with the help of chain or the belt mechanism. So here you can see it's a drivetrain of Ather 450. And what they have used the motor, and there is a reduction pulley mechanism, and with the help of belt drive, it is connected to the wheels. And in other cases, apart from belt drive, the another option you get is to use the chain drive mechanism. Okay, so this is the simple one model. Basically, it's a drivetrain. So they have used the chain and sprocket mechanism to operate their vehicle. So these are the two options you can go with when there is a mid drive motor available. So do you guys know any other sort of drive or the transmission mechanism that could be used here? Or let's drop this question. What are the difference of having
CVT, sir. Continuous variable transmission.
Yeah, CVT could be
In
used in IC engine application, but as
and manual transmission, automatic transmission.
yeah, great. So those are like in terms of four-wheelers, but in two-wheelers you cannot have heavy gears and all such things.
Yes, sir. Yes,
When
sir.
you already have electric motor, it
Hmm.
covers the long range of RPM. So you no need to have some gearing mechanism and all such things. And one advantage it comes with, it gives very high initial torque. So there also you no need to have some first high delivery torque first gear and all such things. So let's talk about the belt drive and chain drive mechanism. So what do you think? What the advantage of having belt drive is from the engineer perspective?
Where in belt drive, sir, we can't have any heat generation, and
Yeah.
in chain we are having the heat generation process, by
Mhm.
which means we need to apply the oil again and again,
Mhm,
and
mhm.
wear and tear
Yeah.
might be happen during the chain. And for belt, it's more nowadays we are using mostly for belt drive, sir. And
Mhm,
even
mhm.
there is another system called shaft drive,
Shaft drive is there. Yes.
And
but
maintenance for
we
men.
don't use shaft drive, so we only depend on chain drive,
Mhm.
or if not belt drive.
Yes, great. So I would also like to add to Salman's point that belt
Space.
drive belts are more, we can say, are cheaper to manufacture as compared to chain drive, and it's also lighter in weight. Okay, so lighter the weight, we can like reduce overall weight of the vehicle. And in terms of belt driven mechanism, we don't need any kind of lubrication, right? Because there are no such like metallic components, so lubrication is also not required, high lubrication. But in terms of belt driven vehicle, sorry, chain driven vehicle, you must have to have the proper lubrication of to like make give it the envelope with the environmental conditions. It might get rusted and all such stuff, so it has to be properly lubricated. So that sort of limitations are also there when you put additional mechanism. But there are some good advantages of having the in mid drive motors basically. So in terms of performance, if you see, like if you are using hub motor, you completely rely on the motor's performance. So whatever maximum rpm that motor can produce, it will be the only thing that you can have at your wheels. You cannot enhance it, and whatever torque the hub motor is generating, that only will be the maximum torque. You cannot play with the torque and rpm in any circumstances. But when it comes to the mid drive motor, you can increase the torque as per your requirement, or rpm as well. Okay, so what
Sir, hello
yes,
sir.
yes, I
While you are telling RPM, why are you writing RMP, sir?
yeah, I'm sorry, I it's mistake, so it's rpm basically. Okay, so what we can do in including high gear ratios, okay, gear ratios, or we can say transmission ratio, we can have higher torque at the wheel, and we can also achieve maximum rpm. So that sort of performance parameters we can play with when it comes to the mid drive motor. Okay, so now as you guys already know about what hub motors are and what mid drive motors are, so what we will try to do, we'll try to compare both the architecture that can be used in electric two wheelers, and we'll try to conclude on what which one will be better to use. Okay, and yeah, so that thing we will talk about. So you can see it's a tvs model which has hub motor, and it's simple energy sorry, simple one model. So we'll on the basis of different parameters, we'll compare the using hub motors, how it can be advantageous, what are the limitations of that, and also in terms of mid drive motors. So first thing we will talk about is fitment. So it's easy to install in a vehicle, as when it comes to mounting the vehicle, you don't have to have a separate compartment or separate mountings of vehicle. Like what happens when you install motor, you have to fix it in a chassis very rigidly, because it's a rotating component, yeah, right? And it creates very high vibration, noise, and all such stuff. And if you are not fixing it or mounting it in a chassis very properly, it could damage the chassis and the overall performance of the vehicle and comfort of the ride basically. So in when it comes to having hub motors, you don't have to worry about the mounting of vehicle. It is always going to be inside the motor, inside the hub of the wheel. So that's the first thing about hub motors. But when it comes to mounting or fitment of mid drive motor, So you have to select a specific point in a whole vehicle region so that the dynamics of the vehicle can be balanced, and along with that the transmission will not be very like distance from motor to wheel should not be very long. As the distance increases, the efficiency of transmission it decreases, so you also need to consider that. So in terms of hub motor, there are no transmission losses as it is directly connected in wheel. But in mid-drive motors, as far you go from the wheel, you will encounter more losses. So that's the thing with the fitment. So I suppose in fitment, the hub motor can be given 1 point, and the uh, mid-drive motor will not score a good level of point. So, what are your takes on this? May I know your opinion in terms of fitment only? We will talk about other parameters later on.
Well, the belt-driven actually increases the center of gravity, so that
Mm-hmm.
might be a disadvantage, but it's actually helpful with the space management.
Mm-hmm.
We
Yeah,
can, and
definitely.
actually, it's a big advantage in the points of aesthetic as well. You can have a cooler looking two-wheeler with the
Mm-hmm.
belt system.
Yeah. Ayush, that's correct. So that's the thing with the fitment that you directly fit it in a vehicle wheel. Okay. So and when next aspect we can look them both as the maintenance. So which will be easy to maintain and can have a long life. So if we talk about hub motors, uh, there are no such moving parts at all. So it's just a motor attached to the wheel. So there are no such high maintenance cost in terms of hub motors. But when it comes to maintenance of in mid-drive motors, what it will be there are other mechanical transmission systems available. So you have to like lubricate it properly and take care of those components. So that sort of thing is there, and these motors are like they when windings are burn out, so it gives a high maintenance cost. But in terms of BLDC motor, it's not that much hub motor. So there also we can say hub motors could go well. And when it comes like when tire is punctured, as someone was talking about it, so it's difficult to remove the tire and to like change the tube and all such thing. So that's the disadvantage of having hub motor. This thing any mechanic who is familiar with replacing the tire or removing the tire can do. But in terms of hub motor, it has to be a skilled worker or skilled mechanic who can remove the electrical connections there, and it can like without damaging the motor, it can remove the tire from vehicle. So that thing in terms of maintenance are also has to be taken care of. Okay. And next thing is the performance. So
सर
yes, please.
सर ये जो हब मोटर है उसमें डिस्क ब्रेक कैसे लगेगी
So
अथवा कोई भी ब्रेक कैसे लगेगी
yeah, so some hub motors they also like come equipped with the drum brakes inside them, or there are like specific or we can say dedicated disc brakes are attached to that. So as soon as you don't accelerate, motor won't run, but you brake it, so it applies the brake. So I guess in previous slide somewhere it's there that vehicle. Yeah, you can see here.
But
So hub
wouldn't this
motor,
add on to the heat generation in the tires?
yeah, definitely. It surely adds to the heat. So that's why these motor can't be run on very high RPMs because there are limitations of heat and all. Okay. Yeah. So we were at the performance point. So
Sir,
in
I have a doubt, sir.
yes, please.
Can't we use tubeless tires for the fit motor
Yeah,
to avoid?
but when tires are burst or like they are completely worn out, so we surely have to replace them, right? And at that moment, it's difficult to get replaced because a motor is attached there. So all the general mechanics can't do all those things. So that's why.
And even tubeless tire gets punctured, sir.
That tubeless tire also get punctured. definitely. So moving ahead with the performance part, in terms of BLDC hub motor, we get the limited performance, right? Because we talked earlier, it comes with the low speed and like the torque which we are getting is limited to what motor is producing. We cannot make it more at the wheel side, and that's why we cannot have the high performance vehicle build by using hub motors. But in case of mid-drive motors, whatever bikes you see now, which reaches around 80 kilometers, 90 kilometers, or even 100 kilometers that manufacturers are claiming. So they are all using mid-drive motor mechanism, because it is the only way we can achieve the high performance, right? Because we can enhance the torque by integrating the high transmission ratios, and RPM also can be increased. So that's how we can get high performance by using mid-drive motors. Okay. And other parameter we can see is efficiency. So we already talked a lot about efficiency. So BLDC hub motors maximum efficiency they can reach is 85 to 90. That also in certain like specific region, not the entire operating range. But in terms of mid-drive motors, there are various types of motors available. Induction motors can be used. Okay. Then PMSM, permanent magnet synchronous motor, switch reluctance motors. So there are different options available. And when it comes to PMSM, they are very highly efficient motors. About 95 to 98% of efficiency they can have. So we can achieve high efficiency when we are using the mid-drive motors basically. Okay, but we have to consider the transmission losses as well. And then comes the very important aspect, dynamics, which affects the ride quality. So dynamics is something from when vehicle is moving, how the vehicle behaves. So when you talk about when you install a hub motor in a vehicle, it adds like it imbalances the overall vehicle dynamics. So in front wheel, like if we say this is the front direction, I'm just drawing it as a bicycle. So if this is the first direction, there is no weight here, or we can say just spokes are there, wheel spokes or alloy wheel. But there is like 8 to 10 kg of weight inside the wheel. So what happens? The CG of the vehicle is shifted at the back side. CG is nothing but the center of gravity, which has to be in a proper place or somewhere around very much middle of the vehicle, so that the balance of the vehicle is maintained. But when you use hub motor, the CG shifted backwards and it completely affects the ride quality. So which is not desirable or not advisable when it comes to making the electric two-wheelers. So that's how it affects the dynamics of the vehicle. And when we talk about mid-drive motors, they are placed at the middle, right? So if it's the vehicle, so they are placed somewhere here. So that's how it balances the CG position, and that's how we can achieve the good comfort and good ride. Okay.
Better maneuverability as well.
Sorry, Ayush, I didn't get. Can you repeat?
Better maneuverability as well.
Yeah, exactly. So those are the terms when it comes to dynamics. Yeah, and there is one more point. So the suspension basically. So what happens? You are putting the hub motor inside a wheel. So it adds to the unsprung mass of the vehicle. So do you guys know what is the sprung mass and unsprung mass in terms of vehicle dynamics?
No, sir.
Yeah, the mass that is actually supported by the spring is a sprung mass, but the mass underneath the suspension is the unsprung mass, which is the
Amazing.
motor gear.
Yeah, great job, Ayush. So it's clear very much from the term itself. Sprung means which is attached to the spring, and unsprung means which is not being attached to the spring. So if we say this is a wheel and this is the let's say suspension, so whatever the mass is, or the body of the vehicle, basically it's above the spring, and spring is carrying the load of this particular mass, so it becomes sprung mass. Okay. And the wheel or the tire, the suspension is not providing any kind of effect on the tire, so it's unsprung. Okay, so what engineers tend to do is we try to reduce unsprung mass because uh, it affects the overall dynamics. How? Because if there, let's say there are some bumps or something in on a road, so if it hits the tire, if more is the mass, it's gonna affect the ride comfort, and lesser the mass, suspension can take those jerks. So that's how suspension will reduce those shocks when before it reaches to the rider. And if more is the unsprung mass, it will highly affect the overall ride comfort. So reducing the unsprung mass is what engineer tends to do. But when you add a BLDC hub motor inside a vehicle, it increases the around 8 to 12 kg of weight inside a wheel, which is like it highly affects the comfort of the riding. But in case of mid-drive motor, there is no such thing. The wheel is completely empty. Just mass over the wheel is the brake and the chain and sprocket. So which is way less than mass of the BLDC hub motor. So you get a better ride quality here. Okay, so hope you guys got this point.
Yes, sir.
Cool, amazing. So that's how when it comes to dynamics perspective, we can go with the mid-drive motor. Okay, then the last point, not last, but the cooling. So when it comes to high speed motors, it has to be cooled, right? If motor is getting heated, it will like in terms of heat, it uh, loses the performance, or the loss is in generating the heat, it loses its efficiency. So what happens, we have to cool down the vehicle, we have to reduce the temperature. So in terms of hub motor, it we cannot provide a dedicated cooling mechanism because it's at the wheels, so we cannot attach any kind of liquid or air cooling system here. It just gets cooled where by the air that it comes in contact with. But in case of mid-drive motor, we can provide dedicated liquid cooling mechanism or some sort of fins and all, which like if whatever the air is coming from front side, so it can be directed towards the motor to reduce its temperature. So cooling can be achieved in terms of mid-drive motor. But in terms of BLDC hub motor, you cannot provide dedicated cooling system. And lastly, the longevity, or which will last long, or which will be like more robust to when it comes to the environmental conditions. So BLDC motor, it's completely exposed to the environment which is there. And as it is very much close to the wheel or the ground, what happens, whatever dirt or mud will be there, water, so it will directly go in contact with BLDC hub motor. And if IP rating is not like that much high, so all the environmental conditions which are there, it will affect the longevity of this BLDC hub motor. But in mid-drive motor, it's completely enclosed inside the vehicle body, so it won't be in contact with any sort of environmental abuse and all such thing. So that's how we can say it will have a long life. So these many aspects we can see, or like there could be more things. If you guys know, we can judge, or we can discuss on which type of drive mechanism would be suitable.
Sir,
Yes, yes.
So, sorry, sir. Once again, sir.
Mm-hmm.
Once again, could you please repeat the question, sir?
So I wanted to let know what all things you can judge this, or you can set parameters to judge this kind of different mechanisms, because these are the things that I could find and I listed down. But is there anything, any parameter we can judge this, or we can compare these sort of things?
Yes, sir. Yes, I am having a question, sir.
Please.
In our pre-university in physics, we have learned that pulling is easier than pushing. Example like pull-a cart or horse cart. It can be done in IC engines or with mid-drive, but very complications will be arriving, sir. But with the hub motor, we can
Mount it in a
uh,
front wheel.
yes, sir. Yes, sir. In
Yes.
four-wheelers, we will mount the drive unit to front or rear
Mm-hmm.
wheel or four-wheel drive. Why can't we mount the driving unit to the front system?
Mm-hmm. Yeah, sure. Like in terms of IC engine, you cannot mount engine directly in the front wheel, but in terms of motor, you can mount the hub motor in the front wheel, and you also it won't be affecting the changing the direction and all. So that's also the steering or that comes under the dynamic or in dynamic of the vehicle basically. So that also the thing that we can consider while selecting the position of motor where it has to be put. Great, Salman.
Does any efficiency will be increased, sir, if we replace the motor at front?
Replace the motor at front. So like you are saying, instead of putting it in a rear
Rear
wheel,
wheel?
if you put
Hmm.
on a front wheel,
Yes, sir.
will it affect? Uh, I hope it won't affect that much. But yeah, what happens when you are riding? If there is a jerk from the front, it's like the jerk. What happens when there is a bump or something? Your first front wheel what it comes in contact with that
Mm-hmm.
first, so it might put the vehicle in danger condition, because at rear wheel it's not that much. Vehicle already get slowed down when the
Hmm.
first wheel come in contact with the speed breaker. So
Yes, sir.
by the like if you are riding at a very high speed, let's say, so if it hits the bump at very high speed, it could result in a hazardous situation. So that's why it is not preferable to put it in a front wheel basically.
Yes, yes, sir. Other than bump something like that, sir, if we make some
Hmm.
good suspension or if we lock the speed or something,
Hmm.
does the efficiency or speed or something increases, sir?
Actually, I didn't get your question exactly what you are
if
trying to
if we
ask.
if we neglect the what you the point what you said the
Hmm.
bump or that point, if we
Hmm.
improvise the suspension system, front suspension system, like
Hmm.
telescopic
So,
upside or downside.
no matter what suspension you use, Mohammed,
Hmm.
Salman,
Hmm.
the thing that comes in contact is the tire and motor. Suspension, then again we come with the sprung and unsprung mass. Suspension will always be gonna behind the wheels. So no matter what level of suspension you use, it's the wheel that is coming in contact with the bump. Okay, so it will surely hit the motor, and it might affect the internal construction of the motor.
Yes, sir.
Mhm.
But in sports bike or in sports area road, the way where the bikes we
Mhm.
gonna racing, there we won't be seen any bumps or uneven road surface. The
Mhm.
road will be smooth and flat.
Yeah,
So what if we?
in those
Yes,
cases
sir.
we can add additional or assistance motor in a front wheel as well, not like completely prime mover kind of thing. It can assist the engine which is there. If it's a hybrid or if it's complete EV, then main could be put there, and like both the wheels could be equipped with two different motors to get the high performance. Yeah, that could happen, but
Yes,
it
sir.
what having multiple motors, what it will do, it will increase the complexity of controller and all such thing.
Hmm.
Because controlling two different motors it's going to be different, the difficult task basically. Okay.
Yes, sir. Thank you,
uh,
sir.
yes. So is there anything else, because I guess it's almost 7:30, so if there are certain things from you guys, so we can just have it discussed quickly, or else we can conclude today's session.
Sir,
Yes.
sir, recently we have seen one advertisement, sir,
Hmm?
one ad,
Hmm?
that Wala S1 Pro got fired.
Hmm. Could you please
What is
repeat?
the Wala S1 Pro
Ola S1 Pro.
new one came, sir, recently.
The incident
Sir,
that it caught fire, that
incident,
thing
sir,
you're talking.
yes. What is the cause, sir?
What is the cost? So actually, I haven't digged it yet what exactly the cost was, but as I talked to the experts, so they were like, I was having discussion in on those topics. It's a very hot topic nowadays in all EV domain. So basically, the climatical conditions, which like high temperature conditions are there nowadays. It's summertime, so the battery couldn't sustain that thing. That could be one reason. And the BMS which is there, it couldn't balance the cell or the battery thermal management which was used, and the bus bars which were connected. So they were, I suppose, were not at that much capable of handling that much temperature. So that sort of thing might have affected, but I am surely gonna research on that, and wherever I get to know about this, we can discuss that thing as well in upcoming sessions when we talk about relevant things.
Okay, sir. Okay. Thank you.
Yes, yes,
Sir, one last question, sir.
yes, yes, please.
So why government is in how do I say, mm,
Yeah, you can talk in native language as well.
like the persons whom we are driving, they does not need to have a valid license or valid
Hmm.
paperwork. Why government is allowing, sir?
No, you have to have driving license when it comes like driving the vehicle which is more than 25 kilometers hour of speed. So you must have to have driving license.
Okay, it depends upon the speed of the
Yeah,
vehicle. If the
yeah.
vehicle reaches around 30 kilometer per hour,
Hmm, hmm.
then the driving license is mandatory.
Yeah. Hmm, hmm, hmm. So that's the thing.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Yes, yes. Okay, then if there are no such points to discuss from your end, I really appreciate you guys attending this session. So we will just review once again what exactly we saw. So we talked about some history of two wheelers, like in 1890s it started, and people started adopting it. But since the technology uh, got advanced in IC engine domain, so we shifted to that technology, and now we are again having electric vehicles nowadays because we understood the harmful emissions which are there. It's affecting the overall climate of the earth. So then we talked about what different two wheelers are there in the market and what could be the futuristic models. Then we detailed discuss about what hub motors are, how they work, and we saw certain calculations that can be performed to understand the maximum speed that we can achieve by using the LDC hub motor. Then we also looked at certain limitations of hub motor, like in terms of efficiency and torque. Then we understood the how mid-drive architecture works, chain and belt mechanism, what are the advantages, disadvantages of having each of them. Then we compared both types of things, whether it's hub motor or the mid-drive motor, and on the various parameters we judge them in terms of performance, cooling, maintenance, fitment, cost, all such things we looked at them. And we had a very amazing discussion on that, and I hope you guys enjoyed the complete session today. Okay, so thank you very much
Yes, sir.
everyone for attending today's session, and a great thanks to Mr. Srinivas Rao and GMR Institute of Technology who took initiative to participate their electrical mechanical branch students in such a session, like which enlighten you when with the current latest technology which is there, so which is electric vehicle, and it's the complete future of automotive industry as of now. So I really thank everyone from GMR Institute of Technology attending today's session. Yeah, Mr. Srinivas Rao, you have some words to let students know.
Thank you. Bye, sir. Good night.
Okay. So thank you very much everyone for attending today's session. And what I will do, I will just drop one link in the chat box so that there is a small feedback form that you can go through. Okay? And you when you fill that form, you select the particular domain you want to learn about, and you will get a free course for that particular domain. Okay, so you can just go to the link that I am sharing, and you select the domain, and for that particular domain you will get a free course from ATG to work on, and the 25% of the people enrolled in that particular program, the first 25% who finishes that complete free, which is from ATG, so you will get certificates for that. So I request you guys to fill up the form and mention what exactly domain you want to learn and explore technology in, and you will get free access to those programs. Okay. So yes, everyone, thank you very much for attending today's session, and keep learning, keep exploring.
Sir, where is that link, sir?
Yeah, it's in the chat box. I just pasted it.
Okay.
I will do it again.